In this episode, we'll dive into creating complex hard surface models faster and more efficiently than ever. A must-know skill for every artist. Hello friends, and welcome to episode 5 of Master Hard Surface. Without wasting any time, let's jump right in and start creating our very first piece, a mechanical part. Let's create a cylinder, scale it along the y-axis, and then use BoxCutter with the join operation to add a box on top of our model. Next, let's select the corners of our box and apply a bevel to smooth them out. Let's add an edge loop here to make sure we don't run into any issues later when we apply the bevel. After that, we'll use the mirror modifier to replicate these changes on the other side. Now let's pull the side section forward a bit and then add a bevel to it to soften the shape. Next, we'll use BoxCutter along with the radial array and HardOps to create the circular holes on our mesh. Now let's take the side parts again and, using extrude and inset, push them closer toward our final shape. After that, we'll use the BoxCutter tool to create the detail cuts on our mesh. For the top section, where we want to place the screw holes, we'll be using a different method. But before that, make sure you have the add-on machine tools installed, and in the settings, make sure to enable thread. Now you can select the faces around the cylinder. Then, right-click and choose Thread. This will let you add settings, such as screw style, directly onto your model. And finally, use a Boolean operation to subtract it from your main model. Now we're going to apply a bevel to our model. But before doing that, make sure you control the bevel amount. Since some of the edges are very close together, too much bevel will cause them to overlap and create artifacts. Now to connect the points of our model, we'll use the triangulate method. As you can see, in some areas, there are issues caused by unconnected vertices after applying booleans. To fix this, simply connect those points together and add supporting edges. This way, the geometry becomes clean and stable. Next, if you notice that the triangulate method creates unnecessary edges across your model, you can clean them up by adjusting the minimum vertices value. This will remove the extra lines and leave you with a much cleaner mesh. And as you can see, our model came together quickly and cleanly. With just a few smart techniques, we achieved a professional-looking result in no time. All right, let's move on to our second model, a sci-fi inspired cylinder. Let's start by creating a six-sided cylinder, giving us the base shape we need for our sci-fi cylinder. Next, we'll select the top vertices and apply a bevel. This will split them into 6 clean triangles on the top surface. Now select the edges that meet at these triangles and bevel them to smooth out the corners. This time, I want to make the model longer according to my preference and add more details to it. For the middle detail, we create a cut using the box cutter and then apply a radial array according to the reference to achieve the desired cut. After that, we use a bevel to smooth it out. Now we make additional cuts directly into those details using a cylinder as the cutter. Then we apply a radial array to duplicate them around the model, which creates the cylinder's handles. As before, we add more surface details on the body, this time designing areas that will serve as mounting points for the locks. Now we split the top section into 2 parts using the slice mode, giving the lock mechanism a more realistic look and functionality. For the top section, we also use the slice mode, then apply inset and extrude to create additional detailing and make the surface more visually interesting. Now, just like we did for the locker placement, we create a mesh. We create a cut on it, and using inset and extrude, we make a recess in it to form the button placement. As you can see, just like in the previous modeling process, we connect the main vertices, and after applying bevels, we use triangulate. For the rest of the parts, we'll follow the same method to complete the model's topology. The only important note here is, before applying the bevel, make sure the main vertices are properly connected. If they aren't, connect them first. Only then apply the bevel. If you enjoyed this tutorial and learned something new, don't forget to like the video and leave a comment to share your thoughts. Your support really helps the channel grow and keeps me motivated to create more tutorials for you.